This is lesson 2. We're looking at subtraction of fractions here in our fractions book, grade 6. And this is what you need to know. Fractions can be subtracted from each other. Fractions can be subtracted from whole numbers. When you have a whole, you might need to take part away, and that is subtraction. So we're going to be thinking about this when we're looking at the fractions. The first way to look at it is this way. We see our symbol, minus. There's the dash line. That means take away or minus or less, right? So if you start with 4 and you take away 1, you know you have 3. But the only reason I can do that simple math is because my fractions match at the bottom. So if I had 4 parts of 5 and I take away 1 part of 5, now I only have 3 parts of 5. That's my final answer, so I put my 2 lines underneath it. Let's move down the page. Do you notice the denominator's the same? So I get to do it the same way. My denominator's going to stay the same. I only need to look at the top number. I have 6 and I take away 2. If I have 6 and I take away 2, I'm left with 4. That's math I can do on my fingers if I need to. 4/7. So if I have 6 of 7 parts and I take away 2 of 7 parts, then I have 4 of 7 parts. Let's look at this one. It's kind of the same, but it's not because it uses a whole number and a fraction. When you have a whole number and a fraction, you have to do a little extra step. Turn this whole number into a fraction. So instead of saying 1, I'm going to have a whole fraction. So I have 4 parts of 4 parts. I have 4 pieces of something that has been cut into 4 parts. Okay? And now I'm going to take away 1 of those 4 parts. So I had 4 of 4 parts, and I'm taking away 1 of 4 parts. Well, 4 take away 1 is 3, and I still have of 4 parts at the bottom. Okay, let's go on and do the next one. This looks really suspicious. What do you notice? It's almost exactly the same. 6 minus 2 is 4, and the 5s in the denominator, they're the same, so I don't have to think about this one. I just have to look at it and finish it. So I have 6 of 5 parts, and I take away 2 of 5 parts, and that leaves me with 4 of 5 parts. Does this matter that 6/5 is an improper fraction? No, it doesn't. I can subtract really easily when I have that improper fraction because 6 is greater than 2, right? So I can subtract 2 away from 6. But look at what they did here. They have a mixed number. The 2, right? So I have 2 whole things and 4 of 7 parts minus 2 of 7 parts. All right, this is a lot to digest. The 2 isn't going to matter in this problem. And the reason I know that is the denominators are the same. I also know that 4 is bigger than 2. So I'm going to have 2, because that's part of my final answer. And I say 4 minus 2 is 2. And the denominator stays the same over 7. 2 and 2 of 7 parts is my final answer. Do you see how I didn't really need anything to do anything with that 2? That's going to change in other problems when we get there. You'll see. But not yet. We're not there yet. Okay, so let's keep going. So that was number 5. We're moving on to number 6. Here we have our whole numbers, 3 and 2. Well, 3 minus 2 is easy, right? 3 minus 2 is 1. So we have 1 as our whole number. The 2/5 is just going to stay there. It's not being taken away from anything. So 3 minus 2 is 1, and 2/5 hasn't changed. So that didn't change at all. And so it just goes right next to the whole number 1. And that is the final answer. All right, here's another subtraction problem. Now we have two things we have to look at. We have the whole number and we have the fraction part. The denominators are the same. We don't have to worry about that. This side, this 3 is smaller than the 6, and the 1 is smaller than the 2. So we don't have to worry about converting our fractions into improper fractions or anything like that. So we can look at it and notice, because these two numbers are bigger than these two, we can just do the math. 2 minus 1 is equal to 1. 6 minus 3 is equal to 3. And the denominator stays the same, 7. Now, I do want to show you the other way to do this, okay? So the other way to do this is to say 2 is the same thing as 14 of 7 parts plus 6 of 7 parts. Okay, that's what this number is. So that translates down to 20 of 7 parts minus, okay, so 1 is the same thing as 7 of 7 parts plus 3 of 7 parts. And then I just bring that down here to be 10 and 7 parts. So 20 minus 10 is 10 sevenths. And you might say, yeah, but Mrs. Brown, look, this has a 1 and 3 sevenths, so your answer's wrong. But this is an improper fraction, and this is a mixed number. 10 of 7 parts is the same thing as 7 of 7 parts plus 3 of 7 parts, which is the same thing as 1 and 3 sevenths. Now, I skipped all of this work because I made an observation first, and I noticed that the 2 was bigger than the 1, the 6 was bigger than the 3, and the 7, the denominator 7, was the same in both fractions. So I can do my math faster if I take a minute to make observations about the numbers first. Okay? Let's go on to 8. Here we have a whole number, 2, and we need to take away 3 of 5 parts. Well, what do we know about this whole number? We know that this whole number is a combination of 5 over 5, right? A whole 1 is 5 parts of 5 parts. So we got 5 of 5 parts. Think of it this way. If I had a little brick here and I wanted it divided into equal parts and I had 5 parts, I've got the whole brick. But I don't have just one brick. How many bricks do I have? Yeah, I have 2 bricks. Maybe these are bricks of chocolate. So if I have 5 of 5 parts, I have a whole brick cut into 5 parts, and I have a second whole brick that's cut into 5 parts. And I only need to take away 3/5. I need to take away 3 of those 5 parts. All right, well, let's do the math. 5 and 5 is 10 over 5, right? And I can just subtract the 3 minus 3 of 5 parts, and that is equal to 7 of 5 parts. Made it a little bit big, but I think we'll be okay. So we have 10 minus 3 is 7 of 5 parts, of 5 parts, of 5 parts. All right, this is an improper fraction. Improper because the number on the top is bigger than the number on the bottom. That means I need to take that 5 fifths out. So this is the same as 5 over 5 plus 2 over 5 because 7 is equal to 5 plus 2. And that's the same thing as 1 and 2 fifths. This is my final answer. Now, what's something I could have done to make this faster? I did a lot, having to combine it and subtract it and re-separate. That's a lot of extra work. So what could I have done? Instead of combining these here and making them into one big fraction, I could have said 1 plus 5 fifths minus 3 fifths. I could have just left this 1 alone. Remember how we did that in the adding on the other side? So I could have left that alone, and then I would just have 1 plus 2 fifths, and then I would have my 1 and 2 fifths. So this would have been another option that would have been faster to get to 1 and 2 fifths. Okay, either way, it doesn't really matter if you do it a longer way and it's correct, or if you do it a little bit shorter way and it's correct. The idea is that you want to be able to show your thinking a little bit. So being able to write down your thinking, that way, anytime you get it wrong, you can go backwards and see what the mistake might have been. All right, here we have a whole number minus a smaller whole number and a fraction. Remember what I said the last time we did this? We can just subtract the whole numbers. 4 minus 1 is 3. The fraction does not change. It stays 5/9. And that's your final answer. Let's look at this one. We have 3 and 2 fifths minus 4 fifths. Now we need to break this apart. Let's take and break apart the 3 into a 2. That's going to remain that whole number. Remember that extra work we had to do on this one? Let's prevent it. We only need to add 5 fifths to the 2 fifths to be bigger than the 4. So 2 plus 5 fifths, that's the same thing as 1, plus 2 fifths. And that is equal to 2 plus 7 fifths. Now our 7 fifths is bigger than 4 fifths. So now I can subtract 4 fifths. 7 minus 4 is 3 fifths. And the 2 just moves on over. It doesn't get changed. So 3 and 2 fifths, 2 parts of the whole 5 parts, minus 4 of the 5 parts is equal to 2 wholes and 3 fifths. If this is still tricky for you, if you don't know how to do this work, then it's time for you to get out some little scraps of paper and start drawing some models to help you. So you might say, okay, I need a picture of something broken into 5 parts. 1, 2, 3, 4, 5. So I can see here that I need to take away 4 fifths, but I only have 2 fifths. That's a problem, right? So that's something that you can start seeing if you draw little picture models. I want you to try section 2 on your own. I've gone through this whole section talking about different strategies. So I want you to pause the video and go through and figure out this section. The first part that I'm going to show you is picture models that might help you think of ways to solve the problem. And then the second time I'll unpause it, I'll show you the answers. So pause the video and then try your hardest and then come peek back for some help with the picture models and then pause it again and then come back for the answers. All right, pause the video and let's get started. So here are some pictures that can help you with your thinking. You might have here, you might look at your whole piece broken into 6 parts, and then you can see that you're going to take away 5, 6, so that leaves you with 1 part. Here's a picture that shows you 2 whole pieces broken into 8 parts. So 2 whole things broken into 8 parts, and you take away 3 parts. Okay? Here are 3 whole things broken into 5 parts. So each of these is broken into 5 parts, and you're going to take away 1 whole and 2 of the 5 parts. This is more like some of these simple ones. So I didn't draw a sample picture to help you see that because I think that you can do this already. So I'm trusting that you know how to do that because we did it over here. But here's a more complicated picture where we have 3 parts plus 1 of 5 parts. So here's 1 of 5 parts. And we have to take away 2 parts plus a whole 1. And then we can figure out what's left. Again, these are more simple because when I look at it, the denominator is the same. The whole number, this one is less than this, so that works out well. And the fraction parts, fewer parts, more parts. So this one, we can follow the routine we've done on these other pieces. Okay, same with this. There's enough information here for you to do this without a picture, but here it looks like we need a picture. So we have 9 parts, things that are put into 9 parts. So I start with this number. I have 2 whole things and 2 of a 9-part thing. Okay, so when I'm taking away, I have to take away a whole one because that's my whole number. I take away a whole one that's broken into 9 parts, plus I take away 7 of 9 parts. So I'm just going to count them away. 1, 2, 3, 4, 5, 6, 7. Now I'm left with a picture that helps me answer this. So I can use pictures to help me. So you should pause the video and finish this. See if you can't write it out, and then I'm going to show you the answers. All right, if you're watching, you're ready for answers, so let's do this. 1 minus 5/6, there's 1 part left. So I don't have to do all of the math piece if I can visualize that there's 1 part left. We're trying to make these pictures in our head that will help us. So that's your final answer. 2 minus 3/8, I have 1 whole, so I know I need 1 whole. And I have 1, 2, 3, 4, 5 of 8 parts left. So that's my final answer. I use the picture to answer this equation. So that's the thing about fractions is you can make a picture to help you answer the equation. You also need to know how to do the math part. So you have to understand both. But we're working on learning both parts right now. So 3 whole things broken into 5 parts. 3 whole things broken into 5 parts. I'm taking away 1 whole part and 2 of 5 parts. So I have 1 whole part left and 1, 2, 3 of 5 parts. And that is my answer. 3 minus 1 and 2/5 is 3, or 1 and 3/5. All right, remember how I said this is just the math? 5 minus 4 is 1. The denominator stays the same. 1 and 7, 1 of 7 parts. This is the same. 8 minus 3, that's 5. The denominator stays the same. Oh, I forgot to do my 2 lines. Sorry. 5 of 9 parts is the answer. 5/9. Here we have 3 whole things, 1, 2, 3, plus 1 part of a thing broken into 5 parts. So we only have 1 part left. So we need to take away 1 whole part and 2 of the 5 parts. So I'm going to take away this one and I'm going to take away this one. So that leaves me with 1 whole and 1, 2, 3, 4. 4 of 5 parts. Okay, the other way to do this, so this is the answer, but the other way to do this is to say we need this number here a little bit bigger, so we can have 2 6/5 minus 1 2/5, and that's the same thing as 1 4/5. Okay, so there are multiple ways to get to the same answer. So I just showed you both of those. 9 minus 4 is 5 of 7 parts. Here we have all numbers that work out. There's no converting that would need to happen. So 4 minus 3 is equal to 1, and 10 minus 6 is equal to 4 of 11 parts. And that's the final answer. Same here, nothing we need to fix. So 2 is going to transfer over, and 8 minus 5 is 3 of 11 parts. And that's that final answer. All right, here's our big one. We had to draw 9 part things. So we had 2 2/9. So we had 2 wholes broken into 9 pieces and 2 parts. So we're going to take away 1 whole. That was this. 1 whole is gone. And we're going to take away 7/9. So we count out 1, 2, 3, 4, 5, 6, 7/9. That only leaves us with 4/9 left. Let's look at this another way. That's our final answer. To look at this another way, we need to separate this and we need to say 1 11/9 minus 1 7/9. And 11 minus 7 is 4. So 1 and minus 1 is 0, so there's nothing there. So this is 2 ways to look at this same problem. Lesson 2, I worked through the whole thing with you. It takes practice to get subtraction of fractions correct. So if you need any support, go back and rewatch the section that is a little bit tricky, but we're going to keep practicing as we move forward in our lessons.